Alright, let's solve problem F12 36. Peg driven by a forked link OA. So this is pushing this peg in that direction along the path described by RE to the theta. When theta equals pi over 4, the link has an angular velocity acceleration of theta dot equals 2 and theta double dot equals 4. Determine the radial and transverse components of the peg's acceleration at this instant. So we need to solve for AR equals R double dot minus R theta dot squared, and A theta equals R theta double dot plus 2R dot theta dot. So we'll start with the equation R equals E to the theta. Taking the first derivative, R dot equals E to the theta, because the derivative of E to the theta is E to the theta. But now we must apply the chain rule and take the derivative of theta with respect to time, which gives us a theta dot. The second derivative of this, then, we have to apply the product rule with the chain rule. So the first times the derivative of the second, E to the theta double dot, plus the second derivative of the first. So the derivative of the first is E to the theta dot, and then we have this one also, so it's squared. Okay, so at the instant, theta equals pi over 4 radians. Theta equals, or theta dot equals 2 radians per second, and theta double dot equals 4 radians per second squared. Okay, and R is equal to E to the pi over 4, putting that into there, and we get 2.19, and R dot is equal to E to the pi over 4 times 2, and that is equal to 4.39. R double dot is equal to E to the pi over 4 times theta double dot, which is 4, plus E to the pi over 4 times theta dot squared, which is 2 squared. So that one is equal to 17.5. So putting these into previous, AR is equal to R double dot 17.5 minus R 2.19 times theta dot squared 2 squared, which is equal to 8.74 meters per second squared, and A theta, which is R 2.19 theta double dot 4 plus 2 R 4.39 times theta dot, which is 2, and that is equal to 26.3 meters per second squared.